could go like this, or I could go like this. Sir, how this thing relates to conservation of mechanical energy? Is there work done by non-conservative forces? So hello everyone and welcome to LN Overseas. So I'm back with the series that is 45 topics in 45 days. In this series, we have 45 topics, 15 from each subject, and today we are going to take a topic of physics, and that is conservation of mechanical energy. So before directly diving into the concept of conservation of mechanical energy, I would like to discuss some more concepts, right, that will actually make us reach that concept, make us earn that concept. Are you ready? First is the conservative forces. What are the conservative forces? The conservative forces have their work done independent of their path. Independent of their path means, so I have to go from point A to point B. There are many ways, right? Infinite ways, in fact, to go from point A to point B. I could go like this, I could go like this, or I could go like this. So I can choose any path. I can choose any path, and if point A and point B are the same exact point, so work done in going from point A to point B is going to be constant for conservative forces only. So conservative forces are path independent. Okay. So basic example is of gravitational force, right? Suppose you have a plane, right, an inclined plane, and you have to move this object of mass m from this point to the topmost point, right? You could move it like this, or you could move it like this. And as far as the work done by gravitational force is concerned, it will be same for both the paths, because gravitational force is conservative, right, independent of path, right? You can take this object from here to here in many different ways. However, work done by gravitational force will be absolutely same. If you are going from this point to this point, if height is h, it will be minus mgh. No rocket science. And whenever we talk about conservative forces, we talk about the potential energy. Potential energy. And potential energy is the energy stored due to change in configuration, change in shape, size, etc., right? And it is only defined for the conservative forces. However, we never talk about the exact potential energy value. What important thing that we have to discuss is the change in potential energy, delta U. And this thing is defined as negative of the work done by the conservative forces in going from initial point to final point, right? This is the change in potential energy, Uf minus Ui, right? And this is the only definition of potential energy. And wherever we will be talking about the potential energy, maybe it could be spring potential energy, it could be gravitational potential energy, electrostatic potential energy. This is the core definition. We will be starting from here. All right. Okay. So this is clear, right? We will not go deep into the conservative forces. This is the main thing that we require in our discussion. Okay. The next is the work energy theorem. The work energy theorem. This theorem is nothing but the godfather of physics. Godfather of physics. Everything happens under this theorem. In classical mechanics, everything is going to happen under this theorem, work energy theorem, because this theorem has no exceptions. No exceptions, right? What is this theorem? Okay, let me just tell you. that kinetic energy is half mv square, right? We know this thing. So there could be any object moving with velocity v. Kinetic energy related to this object is half mv square. Okay. So there will be some force, or there could be set of forces acting on this block, right? And the resultant force is F. There could be number of forces. Okay. Differentiate this thing. There are many different ways to actually talk about work energy theorem. We are taking this way. So differentiate this thing, dk by dt will be equals to half, mass is constant, 2v dv by dt. Agreed? So from here what I can write, dk is equals to, let me cancel this out, this thing will be equals to, okay, wait a minute, let's not cancel this out, let me write it like this, dk by dt is equals to half times 2, right, times 2, this will get cancelled, times m dv by dt is a times v. Agreed? So this gets cancelled, dk by dt is equals to m into a, F is the force, into v, v is dx by dt. So from here, if I integrate this thing from initial point to final point, so the change in kinetic energy will be integral of f dot x, and that is from initial point to final point, right? And that we very well know is the work done. Now concentrate on this thing. Does this thing discriminate with the forces? No, it could be any force, right? It could be internal force, yeah. It could be external force, absolutely. It could be pseudo force, you bet, it could be pseudo force. And that's how we arrive at the work energy theorem. What does it say? That the work done by external forces plus internal forces plus pseudo forces will result in change in kinetic energy. That thing is absolutely equals to change in kinetic energy of any object. No exceptions at all. No exceptions at all. So as work done is a frame dependent quantity. So whenever you will be applying work energy theorem, you will be selecting a frame and then you will be talking about work energy theorem. And if it is a non-inertial frame, you have to consider pseudo force. As simple as that. That is why we have it, right? So work done by external force, internal force, pseudo force is equals to change in kinetic energy. Sir, how this thing relates to conservation of mechanical energy? I would say a statement that conservation of mechanical energy is a special case of work energy theorem, right? As I said, everything comes under work energy theorem only, Godfather, right? So let us see how we are going to get the conservation of mechanical energy. So work done by all forces. Does this include internal forces? Yeah, absolutely. Does this include external forces? Yeah. Does this include pseudo forces? Yeah, but let us consider inertial frame only, right? Inertial frame only, right? Let us keep things simple. So let us not talk about pseudo force, right? You can actually, this thing is equals to the change in kinetic energy. No rocket science in that. Now this internal forces could be of two types. There could be conservative forces, yeah. There could be non-conservative forces. Non-conservative forces are the forces whose work done depends upon the path taken, such as friction, viscous force, etc., etc. Plus work done by external force. This thing is change in kinetic energy. Yeah. Now I am writing a big if. If work done by non-conservative forces is 0. If work done by non-conservative forces is 0. It is the work done. There could be a case where conservative forces are present but the work done is 0. There could be a case. So you have to look at the work done, right? So this does not mean that the non-conservative forces are absent. So friction could be present, but work done by friction, if that thing is 0 for your frame, then what is going to happen? Let us see. Work done by conservative forces plus work done by external forces is equals to change in kinetic energy. Yeah. So work done by external force is equals to change in kinetic energy minus work done by conservative force. Now what is negative of work done by the conservative force? Beginning of the lecture, that is the change in potential energy. No rocket science. So from here, what I can infer? That whatever will be the work done by the external force will result in change in kinetic energy. Definitely. It will result in change in potential energy. Definitely. And these two together will give you change in total mechanical energy, right? Total mechanical energy, isn't it? So this is the work done by external force that will result in change in total mechanical energy. Yeah, nice, interesting. Now again a big if. If work done by external force is 0, only then I can say there is no change in total mechanical energy, or total mechanical energy is constant. That is the conservation of mechanical energy statement. So what are the two ifs that we have to consider? First if, that work done by non-conservative force is 0. If work done by non-conservative forces is 0, also there is no work done by the external forces. They could be present, but the work done by external forces is 0. Only then the total mechanical energy is conserved. Only then, right? This is a conditional statement. So whenever you have to apply conservation of mechanical energy, you have to check for this thing, you have to check for this thing and apply it directly, right? No rocket science. Yeah. Nice. Moving ahead, let us take an example to understand this thing. Okay. An inextensible, flexible and homogeneous chain length L is equals to 2 meter can move along the incline having a shape of an isosceles triangle with an apex angle of 2 alpha, where alpha is 37 degrees given, and located in a vertical plane. Okay, no issue in that. There is no friction between the chain and the incline. No friction. What does this signify? The non-conservative forces are absent. So work done is definitely 0, right? The opposite is not true. If work done by non-conservative forces is 0, that doesn't mean that it is absent. But if it is absent, work done by non-conservative forces is absolutely 0, right? Find the lowest initial speed of the chain necessary to overcome the inclined hill of height h is equals to 3 meter at the initial moment. The position of the chain is shown in the figure. Okay. So, we have this chain having length L, something like this. They are saying that what must be the minimum value of this V so that the chain is going to go to the top of the incline, right. So, it has to overcome the incline. That means it will become like this. Are you sure? Think again. Think again. Sir, if I throw this chain like this, that means the chain has to become like this and it will stick to the incline, isn't it? So, what is my final condition? My final condition is the chain will become something like this. Initially it was like this, finally it has become like this. Now what? Conserve the mechanical energy. First thing in our checklist, is there work done by non-conservative forces? No, that is 0, that is true. Second thing, to check there is any external force acting? No, we have given it velocity, right? But during the course, during the 2 points where I will be applying the conservation of mechanical energy, there is no force acting. Getting the point? So, that means initial kinetic energy plus potential energy is equals to final kinetic energy plus final potential energy, right. So, either you write it like this, delta total mechanical energy is 0, right. Total mechanical energy is change in kinetic energy plus change in potential energy is 0, or Ki plus Ui is equals to Kf plus Uf, right. You can write it like this, right, no problem in that. So, let us calculate the potential energy in the first case. Kinetic energy is easy, right. What is the mass? Say mass of the chain is m. Kinetic energy is basic. Initial kinetic energy is half m v squared. Yeah. What is initial potential energy? That is the point. So, can I consider this chain as a point object? Yeah. Where that point object will be situated? At the center of this chain. Agree? If I consider this as my datum, right, this as my datum, then let us calculate how much is the potential energy. Okay, that means I have to find this length first. Okay, they are saying that the complete length is h. So, do you agree that this complete length will be equals to h by cos alpha? Yeah, h by cos alpha. This is h, this is h, this is alpha, this is alpha, this is h, this will be h by cos alpha, and this distance is L by 2, right? Yeah. So, how much will be this distance? The remaining one, this distance, this distance will be equals to, sir, h by cos alpha, yes, h by cos alpha minus L by 2. This is the complete distance. So, in this triangle, what we have to find? We have to find this length, isn't it? This is my requirement. So, if this is the hypotenuse, this will be the base because this is alpha. Then again apply trigonometry, then take the cos of this thing, you will get the height. So what is the cos of this thing? This thing will be h by cos alpha minus L by 2 times cos alpha. Any problem in that? No rocket science. Yeah. So what will be the initial energy? That will be minus of h. Let me multiply this thing inside. mgh, right? Minus of mgh, mg, and what will be h? This is h. So this is h minus L by 2 cos alpha. Right? So this is the initial potential energy. What about the final potential energy? Final kinetic energy? We need to get the minimum velocity. Right? That means at the topmost point, the velocity will become 0. What is the final potential energy? Let us see. This is our datum. We need to find the height of the CG. Right? CG of this thing. How much will be this length? L by 2. Do you agree? The chain is going to cross the incline when half of the length will be on the other side and half is on this side. So L by 2 will be here, L by 2 will be here. And this length will be L by 4. What is this length? L by 4. That is the distance between CG of left part and the datum. Right? The inclined distance. Okay. So for the other side as well, this will be L by 4. Yeah. So that means CG are going to lie on the same line. Yeah. That means you are going to find CG at the center somewhere here. Definitely. So that means if you draw this triangle, this is L by 4, this is alpha, you need to get this thing. Definitely you have to get the height, right? So what will be the height? This will be L by 4 cos alpha. So that is the height of the CG of the chain from the datum. So now this thing will be equal to minus mg into L by 4 cos alpha. Right? Now what we have to do? Ki plus ui is equals to kf plus uf. Right? So ki is ki plus ui is equals to kf plus uf. Ki is half mv square. What is initial potential energy? Minus mg h minus L by 2 cos alpha. Right? This thing is equal to 0 minus mg L by 4 cos alpha. Right? You have to find V. So half mv squared is equals to mgh. This thing will be plus minus L by 2 cos alpha, and remaining is mg is also there, my bad, mg is also there. So mgl cos alpha by 2 and then minus of mgl by 4 cos alpha. Right? So if I cancel this thing out, this is 2, this gets cancelled, this is 2. So m gets cancelled. You will have v square is equals to 2gh and 1 minus 1 by 2, or minus 1 by 2, that is minus of 3 by 2 gl cos alpha. Substitute the values. So this is 2 into 10 into h. What was h? 3, isn't it? Minus 3 by 2 into 10 into L was 2, I think. Right? L was 2. And this was 2, and what it was? This is cos alpha. What was given in the question? Let me check. Alpha is 37 degrees. This is 3 meter. And the position of the chain, okay. This is 3, this is 37, this is 2 alpha, and L is 2. No rocket science. Okay, substitute the values. Cos alpha is cos 30 degrees, isn't it? The net angle is 37 degrees. So cos alpha is cos 37 degrees. So this is 2 into 10, 2 into 30 minus, this gets cancelled, 30 into, this is 4 by 5, right? And you cancel it out. This thing will be equals to 6, right? 60 minus 24, right? 36, right? So V is equals to 6 meter per second. No rocket science, right? You can do the calculations, very basic, right? So what we did, we calculated, we took the initial case, initial point, right? We calculated initial kinetic energy, initial potential energy, final point, right? Final case, final kinetic energy, final potential energy. We equated two, right? Why? Because no work done is absent for non-conservative forces and there is no external force acting. So I can conserve the energy. So that is allowed. Then I solved it and it's done, right? Easy peasy, no rocket science. So this is it for today. I hope you have enjoyed this session and you can continue watching the playlist. The link is available in the description box. And if you have any queries, any doubts, any questions, you can drop them in the comments. So thank you and have a nice day ahead.